Law of signs. This section includes use of the law of signs to solve oblique triangles and to find the area of oblique triangles, and then application of law of signs. Oblique triangles. Oblique triangle is a triangle that has no right angle. Angles of triangles are either smaller than 90 degrees or larger than 90 degrees, but smaller than 180 degrees. Sum of the interior angles of a triangle is always 180 degrees. And here is the examples of triangles. This is acute triangle and this is what? Obtuse triangle. Law of signs. For any oblique triangle, the ratio of the length of its side to the sine of the angle opposite to that side is the same for all three sides. So it's side A over sine A equal to side B over sine of angle B equal to C over sine of angle C. So they're all equal. Alternative formula of sine. Sine of angle A over side A equal to sine of angle B over side B is equal to sine of angle C over C. Application of law of sines. We use law of sines to solve oblique triangles that have either of the following. Two angles and any side are given, or two sides and an angle opposite to one of the sides are given. Here's an example. Use the law of sines to solve a triangle. Round your answer to 2 decimal places. Angle B and C are known. So angle B is 45 degrees and angle C is about 105 degrees. So we're going to find third angle A. So since sum of the interior angles of triangle is 180 degrees, so we subtract angle B and C from 180 degrees. So we have 180 degrees minus 105 degrees minus 45 degrees, which becomes 30 degrees. Substitute B is equal to 20 and C is equal to 105 degrees, B is equal to 45, and the angle A is 30 degrees in the law of sines. A over sine 30 degrees equals to 20 over sine 45 degrees equal to C over sine of 105 degrees. To find the value of A, use first two ratios. A over sine 30 degrees equals to 20 over sine 45 degrees. Sine, okay, now to solve for A, multiply both sides sine 30 degrees. A over sine 30 degrees, 20 over sine 40 over sine 30 degrees. Now you can cancel out sine 30 degrees with sine 30 degrees. You're left with A equals to 20 sine 30 degrees over sine 45 degrees. You put this on the calculator and you get 14.14. Use the calculator in degree modes. To find C, use last two ratios of law of sines. 20 over sine 45 degrees equals C over sine 105 degrees. Now multiply each side by sine 105 degrees, and then you can cancel out and you get C on the right side and the left side 20 times sine 105 degrees over sine 45 degrees. You put on the calculators, you will get C equal to 27.32. So solution is A is 141.14, C is 27.32, and A is equal to 30 degrees. Example 2. A tree grows at an angle of 94 degrees from the vertical due to prevailing winds at a point 40 meters from the base of the tree. The angle of elevation to the top of tree is 30 degrees. Write an equation that you can use to find the height h of the tree, and then find the height of the tree. Redraw the triangle shown in the picture as follows. So here is a picture of the triangle. where angle A is 94 degrees, B is 30 degrees, then C would be 180 minus 94 minus 30, and which will give you 56 degrees. Write the law of sines, substitute the available information from the triangle and the one you need to find. We need to find the height, so the B is H. A is 94 degrees, B is 30 degrees, C is 56 degrees, and C is what? 40. So the law of sine becomes A over sine 94 degrees equal to H over sine 30 degrees and 40 over sine 56 degrees. The equation we need is the H over sine 30 degrees equal to 40 over sine 56 degrees. To find the height of the tree H, we solve this equation. H over sine 30 degrees equal to 40 over sine 56 degrees. So let's multiply with sine 30 degrees both sides. So you got, and then you can cancel out sine 30 degrees on the left side. You're left with the H equals to 40 times sine 30 degrees over sine 56 degrees. Put on the calculator, you should be able to get 24.12 meters. So example 3. A 10-meter utility pole casts a 17 meters shadow directly down a slope when the angle of elevation of the sun is 42 degrees. Find the angle theta, the angle of elevation of the ground. Now look at the triangle, the right triangle, and you see A is 180 degrees minus 92 degrees minus 42 degrees equals 48 degrees. Now we apply the law of sine on the triangle ABC. Since you need to find angle of elevation, use the alternative form of law of sine, which is sine angle A over A equals to sine of angle B over B equal to sine of angle C over C. So now in this law of sines, substitute B is equal to 42 degrees minus theta, A equals to 48 degrees, B is equal to 10, A is 17. And you have sine 48 degrees over 17 equals to sine of 42 degrees minus theta over 10 equals to sine of angle C over C. Okay, now take the first two ratios and write the equation, and the equation will be sine 48 degrees over 17 equal to sine 42 degrees minus theta over 10. Now solve for theta. I think we need to rewrite this equation, so it should look like this: sine 42 degrees minus theta over 10 equal to sine 48 degrees over 17. Now multiply both sides by 10. So you see this one. You can see 10 cancel with 10s, and you get sine 42 degrees minus theta equals to 10 times sine 48 degrees over 17. Yeah, now put this one 10 times sine 48 degrees over 17 on the scientific calculator and try to get 0.437144015. Okay, now use the law inverse sine definition, and you will have 42 degrees minus theta and become sine inverse of 0.437144015. Put on the calculator and try to get 25.922 degrees. And now to solve for theta, so you subtract 42 degrees each side. 42 degrees on the left side cancels out, and on the right side minus 42 degrees plus 25.922 will give you minus 16.1. So now divide by -1 and you should get theta equal to 16.1 degrees, and that's the answer. Area of an oblique triangle. The area of any triangle is 1/2 the product of the lengths of two sides times the sine of their included angle. So if we know the side B and C and the angle A, and then you can use the formula 1/2BC times sine A. And if you know A and C, and then you can use 1/2AC times sine B. And if you know the angle C and B and the side B and A, then you can use 1/2AB sine C. So here's an example. So find the area of the triangle. We round your answer to one decimal place. So we're given A is 125 degrees, B is 9 and C is 6. So we'll use this formula. Area equals to 1 over 2 B times C sine of A. So we have 1 over 2, 9 times 6, 9, sine 125 degrees. Use the scientific calculator in degree modes and try to get 22.1. So example 5, find the area of a triangular lot. Find the area of the triangular lot having two sides of length 90 yards and 52 yards and an included angle of 80 degrees. So the area is 1 over 2 times 90 times 52 times sine 80 degrees. Put on the calculator, you should be able to get 23 or 4.5 square yards.